Hello. This video, using System Tuner Studio, STS, shows how the optical laws of reflection and refraction comply with Fermat's principle. In other videos, such as D010, D020 and D105, the structure and operation of STS have been explained, so only the programming of the system and the figure of merit will be emphasized. Fermat's principle states that light travels between 2 points along the path that takes the least time, compared to other nearby paths. From there, the law of reflection will be verified, which states that the angle of the reflected ray is equal to the angle of the incident ray. Due to this law, images like this can be observed. On the other hand, based on Fermat's principle, the law of refraction or Snell's law will also be verified, which establishes that the relationship between the sine of the angle of incidence and the sine of the angle of refraction is constant for two given media. This constant is equal to the ratio of the refractive indices. Due to this law, images like this can be observed. The problem to solve is the following. Calculate the path of a light ray that start from a point A in a medium with index of refraction n1, enters a medium with index of refraction n2, is reflected from the bottom surface of that medium, and arrives at point B. Take into account that the speed of light in a medium is equal to its speed in vacuum divided by the index of refraction of the medium. S1 is the distance of the first path to travel in the medium with refractive index n1. And T1 is the time needed to travel this first path. The distances and times for the second and third trips are calculated in the same way. Therefore, the total time required for the light ray leaving point A to reach point B is the sum of T1 plus T2 plus T3. According to Fermat's principle, this time must be minimal. Then, as STS is in charge of maximizing the figure of merit, it can be defined through an inverse relationship with this time. Finally, what is involved is calculating the values of x1 and x2 that maximize the figure of merit. This is system programming. These are the values of the constant parameters. And these are the variables that will be modified until the maximum figure of merit is found. Two arbitrary values are taken as a starting point. This is the figure of merit programming. In this first block, the values of the variables are captured. In this, the array that will allow graphing the path of the light ray is calculated. This array is added to the GR object that will contain all the elements to be graphed. A transparent line is added in order to keep the coordinate axes fixed and to make viewing more pleasant. Labels A and B are added to the start and end points. The medium with refractive index n2 is drawn in light blue. Figure of merit is calculated. And finally, the angles and the relationships related to the laws of reflection and refraction are calculated to verify that they are fulfilled. Now we proceed to find the path corresponding to the minimum time to go from A to B. The tuner is opened and the project is created from its components. The system is loaded. Initial values, variation ranges, partition dimensions are defined and linear axes are maintained. The figure of merit is loaded. And in a few seconds STS gives us a first proposal which is further adjusted by clicking on the tuner button. We see that the results are as expected, that is, Snell's law is fulfilled, as well as the law of reflection. The tuner button is not only for fine-tuning, but it does the calculation starting from any starting point. See results. Other videos related to System Tuner Studio can be seen on the following YouTube channel. Look for it below, in the description. Sophonius team will appreciate your comments. Thank you for your time.